Hey guys, it's Outing here with you in the Pina Colada song, celebrating spring break is so close, and then you can go home and drink all the Pina Coladas you want, non-alcoholic versions, of course, and so good. Unless you don't like coconut, then not so good. Anyways, I want to talk to you really quick about how do you graph a linear inequality. When I say linear, I mean an inequality that makes a line on a coordinate plane. Normally, before we were graphing inequalities on a number line, and these of course are one-dimensional. They tell you in what direction the values exist that make that particular inequality true. So this might be, the inequality y is greater than or equal to 3, graphed right there on the x-axis. Now, when I throw in this extra dimension, that means we're basically going to have something similar to what we've studied before, a linear equation, except now all of the solutions lie on one side of the coordinate plane, because this line is going to split our coordinate plane into two halves. Everything on one half will be a solution to the inequality. Everything on the other half will not. And when I say solution, I mean, of course, it will make the statement true. So, how do you graph these guys? Well, you graph it just like you would a linear equation. So, this looks an awful lot like the linear equation y equals 3 minus x, which, if we rearrange that in slope-intercept form, ends up looking like y equals negative x plus 3, right? Again, that negative sign has to stay with the x when you flip this. That's the associative property of addition. Anyways, when we graph this, we're going to graph it just like a linear equation. We're going to start with our y-intercept, which is 3. And then we're going to use our slope, which negative sign goes with the coefficient of 1, and the slope of negative 1, is the same as negative 1 over 1 as a fraction. Got to have it as a fraction, which means go down 1, right 1, down 1, right 1. Or you could go up 1, left 1, up, negative. And what you end up getting is a line. Now, an important question to ask yourself before you even graph the line like I did, is this going to be a solid or dashed line? And the answer to that question is the same answer to the question when we graphed in one dimension, which was, do we have an open or closed circle in it? It has to do with the sign. If the sign is a greater than, less than, equal to sign, you have the equal to on it, then it will be a solid line. That just tells you that, let's say we choose a point that happens to fall on this line, like the y-intercept, 0, 3. 0, 3 is actually going to make this inequality have two equal sides. That's what the things on the line do. They make both sides of the inequality, or the equation down here, equal. Now, if this was not a greater than equal to sign, this statement would not be true, because, of course, 0 can't be greater than itself, just like 0 can't be less than itself. That's a fallacy. Is it equal to itself or less than itself? Absolutely. So for that reason, we want to include these points as possible solutions to the inequality. And if they're possible solutions, that means we need to mark the line in some way that shows that, yes, anything on the line works. And we do that by just making it solid. If it didn't work, we would change this. We would make it a dashed line instead, which says that everything on one side of the line works, but things on the line itself do not work. They do not make the inequality true. This one does, however, so we'll leave it like this. And then there's that second question you have to ask yourself. Where do you shade? And it's pretty simple, actually. You shade wherever this inequality is true. In other words, find a point that works. Now you might say, oh, 0, 3 works. We plugged that in just a second ago and got this. The unfortunate thing is, if you look at where 0, 3 is located, it's on the line. And if it's on the line, that in no way tells you what side of the line you need to shade on. So in order to figure that out, pick any point not on the line. Our favorite point that's not on the line usually is the origin, 0, 0, just because it's easy. Let me show you just how easy it is. If I plug in 0 for y, I get 0 is greater than 3 minus, and then I plug in 0 for x as well, because the origin is 0, 0. And I end up with this statement: 0 is greater than 3 minus 0 is just 3. 0 is greater than or equal to 3. Okay, I know that that is not true. And if it's not true, that means that is not a working solution. The point 0, 0, this point right here doesn't work. And if it doesn't work, I'm not going to shade on its side. In fact, there's only one other side to shade, so by process of elimination, I'm going to shade on the other side. Now, if you want to check yourself, pick another point on this side. I don't know. How about the point 4, 1? Plug it in. 1 goes in for y, 4 goes in for x, and oops, not like that. Try again. 4 goes in for y, 1 goes in for y, 4 goes in for x. You get 1 is greater than or equal to -1. That's absolutely true, so I know this point works. I need to shade on that same side as that point. Now, you don't have to do that for everyone. If you find a point that doesn't work, shade on the opposite side. If you find a point that works, shade on that side. Basically, this is saying any point in this half plane, not the full coordinate plane, but this half plane, will make this inequality true. It will make y greater than or equal to 3 minus x. The y coordinate is greater than 3 minus the x coordinate, always on this line or above this line, and that's an inequality. Now, I do want to give you a little extension because some of you I know are like, oh, but what about systems? Systems aren't that bad. If I had a system of inequalities, that would mean I have two inequalities on the same graph. And let's say I went ahead and I graphed this one, and I shaded beneath it. Who knows the equation or the inequality that represents this, but notice there's one particular region in which both lines are shaded at the same time, and that happens to be right in here, right? Well, rather than double shading, something we can do is just erase the shading we had before, and we just have one single shading representing where do both of these work at the same time, and in this case it's right here. Since both of them work right there, that's the only quarter plane that gets shaded, so everything in this part of the coordinate plane is a solution not just to one, but to both of the inequalities. I hope that helps. If you have questions about that, feel free to hit me up on the course website or ask a question via email. I'd love to help you. Enjoy your spring break, guys. Good luck on the test tomorrow. I know you guys will do awesome. Thanks.